Okay, this is a KSP problem. Answer the following questions about the solubility and reactions of the ionic compounds MOH2 and MCO3. A. Identify the charge of the M ion in the ionic compounds above. Since we know that the charge of OH is 1 minus and there are two OHs, we can assume that M is 2 plus. Since CO3 is also 2 minus, we know that M is 2 plus for this one as well. B. At 25 degrees C, a saturated solution of MOH2 has a pH of 9.15. Calculate the molar concentration of OH minus in the saturated solution. So, since the pH is 9.15, we know that the pOH is 4.85 because 14 minus 9.15 equals 4.85. Using this number, we do 10 to the negative 4.85
it means that
to
X
find
plus
the
is not
concentration
good
of
enough
OH
to steal
minus.
electrons from Q, right? So then that means that the least reactive, because then wait, hang on. PV is good enough to steal electrons from Q, but X plus isn't good enough to steal electrons from Q.
We find that the value of the concentration of OH minus is 1.4
PV
times
steals
10 to the
electrons
negative
from Q,
fifth
and
m.
it steals electrons from X.
Part 2. Write the solubility
right.
product constant expression for MOH2.
PV loses electrons from Q.
Since there are two OHs, we know that OH minus will be
So,
squared.
does that mean that
And since there is only one M2 plus, it will just be M2 plus
PV should be
in
the
the
most
bracket.
reactive because the metal wants to lose electrons. So if it will lose
Number 3.
electrons,
Calculate the value of the solubility product constant KSP for MOH2 at 25 degrees C.
which is more reactive, the one that will lose electrons or the one that won't let it lose electrons? Do you know what the answer is?
Since we already know the OH concentration, and since OH is double that of M2 plus, the M2 plus concentration will be half of the OH concentration.
Like
And also
X
the OH concentration will be
can't
squared.
be Q.
Okay.
Alright, try to explain. This is the key one, isn't it? That X is able to
Would I
steal
just text
electrons.
it to you, Georgia?
So Q will react with X. No, it won't react. X is not able to steal electrons from Q, so Q does not react. PV,
We find that the value of the solubility product constant is 1.4 times 10 to the negative 15. C.
PV steals electrons
For the
from
metal
PV.
carbonate MCO3, the value of the solubility product constant KSP is 7.4 times 10 to the negative 14 at 25 degrees C. On the basis of this information and your results in part B, which compound MOH2 or MCO3 has the
So we
greater
know
molar
that
solubility in water at 25
X
degrees
are
C?
gonna be in the
Justify
bottom
your answer with a
because
calculation.
they don't react to each other.
Since MOH2
that,
has a smaller KSP than MCO3,
Lead is gonna
we
be the
can
top one.
conclude that
Maybe that's the best way to start. You know that lead is going to be the top
MOH2
one because it reacts
has
with
greater molar solubility in water at 25 degrees C than MCO3.
both Q and But why is
D. MCO3 decomposes at high
because
temperatures
I
as
think
shown by the
it's
reaction
metal
represented below.
is more reactive.
MCO3 solid
Since Q
leads to
electrons
MOS
X,
plus CO2
then it's not
gas.
reactive.
A sample of MCO3 is
But I wish
placed
they
in a
would've
previously
given-
evacuated container, heated to
They
420
should have
degree,
given
3
you
degrees Kelvin and
what
allowed
it's
to
got here is
come
that
to equilibrium.
X
Some solid MCO3 remains in the container. The value of the Kp for the reaction at 423 degrees K is 0.0012. I.
Like if the 4 were going
Write
to
the
go,
equilibrium
then
constant expression for Kp of the reaction. Since carbon dioxide, CO2, is the only gas, the Kp expression will be Kp equals P CO2.
right.
II. Determine the pressure in atmospheres of CO2 in the container at equilibrium at 423 degrees Kelvin. Since this is the Kp value right here, and Kp equals 0.0012, we can conclude that PCO2 also equals 0.0012 because that is the only value there.
Like it might take the rest of the period, but we have the rest of the period.
I mean, for it to load, like,
Yeah.
yeah, I just had that.
I'm not sure if you mean
Indicate I. Indicate whether the value of change in G for the reaction at 423 degrees Kelvin is positive, negative, or zero. Justify your answer.
Last lecture
Since
said
the formula for the change in G
last
equals negative
lecture
RT ln K is negative RT ln K,
Q would not lose electrons.
and since
So
K is
Q is not reactive.
positive,
Is the least reactive.
Okay.
And X is somewhere.
the ln of the natural log ln of that number will be positive.
Because I think that I agree that was the hardest question.
Since the k is less than 0 in this equation, the natural log of k will end up yielding a negative number. Therefore, when multiplied by the negative number in front of the the gas constant, 0.0821, will yield a positive delta G.
What he said.